A lot of people have been asking like, hey, what is this weird thingy that you are actually designing? Well, as you can see, this is a frequency speaker, and this is actually an art project that I did that generates AI music based on news. So kind of think of like the sentiment of the day from the world news is gathered and generated as music. And this has a radar inside. So every time, say, if you place it in the bathroom or somewhere else and it detects motion, it's going to play the music in a loop for some time. Now, the problem with these Bluetooth speakers is after some time of inactivity, they get turned off. And of course, I had this here to play like a silent tone, subtone every few seconds so that to keep the line in of this speaker to stay awake. But sometimes interval at which that silent audio or A audio, which is very, very quiet, playing to keep the speaker line active, doesn't match, and at some point it gets off. Opening up the speaker, tinkering with the PCB was not an option because I didn't want it to do that. I tried a little bit. You can see some scratch marks here and here, but it was kind of like glued, so I didn't really want it to tamper with it further. So my first idea was, let's take a fingerbot, which like if you put a battery in there and then you press, the lever comes out. These are easily available, and you can see that I kind of hacked it together and plugging in, kind of like, jacking the LDR from the button over here. So bypassing that with the LDR. So pretending that whenever the light here goes off, the LDR turns on and it pretends to turn on the switch, and it should just press the button back on again. The problem was my breadboard circuits with that op amp and a comparator were okay. It was like a RC circuit. First intention was not to use any microcontrollers. It was working, but it was not working very well. So I thought, of course, maybe it's like the breadboard issue and like some other issues and tuning, and it's very, very sensitive. So let me build a PCB. So I built a PCB according to that same schematic, and you can see it here. And I was playing with different capacitor values. Didn't really work out as I intended, and it was getting a little bit janky because I wanted to, and it was not scalable and repeatable. So I ditched the idea and I ended up going with a microcontroller solution, which is what you see here. This is like the basic trial and error. So this has an 8 mega microcontroller over here, and this is like a simple LDR circuit that I was and it has a comparator, so you just get an analog to digital signal. So when it turns on after a certain threshold, it'll pretend to be like a button press, and that I can do anything. For example, pressing the servo here. So I essentially took this, made it into a low power circuit. So improve this comparator circuit. It's a very, very low power comparator, and programmed the microcontroller to be in deep sleep mode, which is then shrunk into this PCB over here. You can see the microcontroller over here, and that was it, right? Like, so all the comparator and everything is in like this super, super small footprint. One of the problem was the servo was constantly drawing power. So in deep sleep mode, the whole system would consume around 2 milliamps, and that was not okay. Let's say if it's 5 times a day, and then it is constantly drawing some current, and accumulatively the whole circuit is consuming 2 milliamps, then calculation wise it will be around a month. See it here, I have it actually installed on one of these, working constantly. This speaker hasn't turned off in, I would say, a week, because every time it turns off it gets turned on again. And but let's see how long the battery on this circuit lasts. So I'm making a new version now, so stay tuned. The next version that I'm doing is having less 3D prints, because there's a lot of 3D printing going on here and a lot of assembly. So now the new design will be much better. It's just like a single PCB. So stay tuned for that. Cheers.